Yeah, welcome back to our class, mathematics class. In today's class, we want to look at some problems that are related to trigonometric function, especially Pythagoras Theorem. Now, let's look at this question on the board, in which one of our students sent to us. The question says, a pole 25-meter long is placed against a wall that its lower end is 7 meters from the foot of the wall on the same horizontal ground. If the upper end of the pole is pushed down by 2 meters, calculate to two significant figures. Question A. How much further away from the wall the lower end will move? Question B. The angle the pole now makes with the horizontal. Now, before we venture properly into this, if you are just coming across our channel for today, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share, like, and leave a love emoji. So, let's get at this question because I'm going to clean it off then so that we can solve properly. Now, going back to the question, a pole 25 meters long is placed against a wall. We know what a wall is. A wall normally stands vertically. That is, let's assume this is our wall. Then, when we say a pole normally leans against a wall. So, the pole leans against the wall. And I said that a pole 25 meters long, which is this pole, 25 meters long, placed against a wall that its lower end is 7 meters from the foot of the wall. The lower end of this pole is 7 meters from the foot of the wall. This is a wall. So this is the foot of this wall. 7 meters from is coming from this place. And it is now 7 meters. Whenever you have a vertical and horizontal, you are going to have an above 90 here. The question now goes further. Says that if the upper end of the pole, the upper end of this pole is pushed down by 2 meters, meaning somebody comes here and pull this. When the person pulls it down, it means this will move down while this will extend forward. So which means that, let me do it this way. So a dotted line to show that this thing is moving down to this place. When it's moved down to this place, definitely the lower end we have to extend. It has to extend. So this is the new position now. So this is the old position. Let's call this one height H1. Let's call this one height H2. So H1, distance from here to this point is H1, while distance from here to this point is our H2. Okay, so from this point to this point is our 7 meters. So let me now say, let's X represent the whole of this length here. So this point. So from here to the end here is X, while from this point to this point is our 7 meters. Let's now move forward. The question says, how much further away from the wall the lower end will move? How much further away? We need the distance from here to this point. How much further away? Let's call that distance Y. This small distance. We need it. But looking at this, how many triangles do we have here? We have two right angle triangles. Look at this. This is the first angle, the normal angle. H1. Look at my hand. H1 to this point, our first angle. So if you look at this H1 to this point, we are given from this point to this point to be 25 meters. Are we here? We are given from this point to this point to be what? 7 meters. So we don't know the height, which is from here to here, which is H1. So let's find out H1. To find the H1, let's take out this our diagram first. So this is our H1. This is the length of the pole, 25 meters. This one is 7 meters. Now from here, you can see that when you are given these three sides, definitely we are going to make use of our Pythagoras theorem that says that the square of the hypotenuse sides is equal to the sum of the squares of the two opposite sides. That is, hypotenuse side is that side facing this box 90. So the side facing this box 90 is your hypotenuse. So the square of the hypotenuse side, 25 square, is equal to the sum of the squares of the two opposite sides, which are what? 7 square plus h1 square. So when you square 25, we have 625 equals to 49 plus h1 square. Now take this one here, 625 minus 49 is equals to h1 square. So let us subtract. So when you subtract this one, we have 576 equals to h1 square. Since I need my h1 and not h1 square, I have to remove that square by squaring both sides. So square root both sides rather, is square root both sides. Square cancel square roots. h1 equals to, so look for the square root of 576. We have it to be 24 meter. So the length of this h1 is 24 meter. Don't forget what we need. What we need is what? Is this value. But they told us that this ladder, this pole was moved down by 2 meter. Distance from here to here is 2 meter. Was moved down by 2 meter. And we all know now that we have gotten the whole length to be 24 meter. If we take away 2 meter from 24 meter, from this point to this point now, is going to be what? It's going to be 22 meter. So our h2 from here to this point, h2 will equal to h1 minus 2. That is 24 minus 2, which equals to 22 meter. So I've gotten my h2 from here to here. And don't forget the length, this h2 has moved further here. Now, and I want to get the value of what? Y. Let me take out the second triangle that says, look at from this h2 to this point, back to this point. Let me again, h2 to this point, back to this point is our triangle. So let's take it out. So now this is our triangle now. So this is our h2, 22 meter. The length of the pole remains 25 meter. Now, I want to get the value of y. But to get this value of y, I must first of all get the whole length. To get the whole length. Now, we now have it to be, using our Pythagoras theorem as usual, the square of the hypotenuse sides. Hypotenuse sides is 25 square. Sum of the two opposite sides, 22 square plus x square. Now 25 square, 625 equals to 22 square. When you square 22, meaning 22 times 22, 484 plus s square. So take this one to this side, 625 minus 484 equals to x square. So let us subtract. So we have 141 equals to s square. What we need is the value of x and not s square. So you square root both sides. Square root of 141, square root of s square, square cancel square roots. Our s equals to, so we have 11.87. They said to two signal figure 11.87. Now, but what we need in the question 1, question A is how far the ladder moved forward. So which means the whole length is x. You know, their x will be equal to, since it's means the whole length, it means sum of everything. That is 7 plus y. 7 plus y is what that gives us the whole length, which is what? X. Our s is 11.87 equals to 7 plus y. So take this one here. 11.87 minus 7 equals to y. So our y equals to, so take away 7 from it. So we have 4.87 meter. Now, the length, now, how much further away from the wall the lower end will move? So the lower end will move by 4.87 meter. Question B says, the angle the pole now makes with the horizontal. We know what we call horizontal. This is vertical, this is horizontal. So the angle it makes, this angle here, let's call it angle theta, is what we need. So let's take out this triangle that is possessing this angle theta. So we have angle theta here. Don't forget the length to be 25 meters. So the whole length that we have now will be 7 plus this, which is 11.87, if you still recall. Then the height is 22 meters. Don't forget, it's our new height when it was moved. Now I want to get the angle theta. When you label this is our angle. Anywhere the side facing your angle, the side facing your angle is your opposite. The side facing this but 90 is your hypotenuse. While the remaining one is your what? Adjacent. So we have 3 sides to get your theta. You can use sine, cosine, or tangent. So anyone. Let me use sine. Sine theta equals to, don't forget from our lessons, go back, you can check our playlist in mathematics to check for our trigonometric lesson. In SOCATUA, if I want to use sine, my sine theta will be opposite over hypotenuse. Opposite over hypotenuse. So sine theta will equal to my opposite is 22. Hypotenuse is 25. So my sine theta equals, so we divide 22 divided by 25. We have 0.88. Since I need my theta, it's going to be equal to arc sine 0.88. Theta equals to, arc means you press shifts, then your sine is going to bring out this sign, arc sine. Then you press your 0.88, press equals to, so you're going to have 61.64. That is 61.64 degree to 2 significant figures. So this is how to go about this question. So we are going to take one more example in order to look at the different ways of setting this question. Let's look at a similar question to the first one. A ladder 10 meters long just reaches the top of a wall 6 meters high. How far is the foot of the ladder from the wall? If the ladder is now moved so that the foot is 2 meters further away, find how far the top of the ladder slides down. Let us take this question down and let's interpret it one after the other, step by step. Back to the question. A ladder 10 meters long just reaches the top of a wall 6 meters high. A ladder is 10 meters long, just reaches the top of a wall. Let's assume we have the wall this way. So the ladder just reaches the top of this wall, and that ladder is 10 meters long, reaches the top of a wall 6 meters high. The wall is 6 meters in height. How far is the foot of the ladder? How far is the foot of this ladder from this wall? So from the wall. So this is the wall. How far is the foot of the ladder? F, foot, F. So this is the wall. This is the height of the wall, and this is the base of the wall. Where vertical and horizontal meet, we have angle what? 90 degrees. Now we're not asked to find how far this distance. Let's call it small letter h. Now using our Pythagoras rule that says the square of the hypotenuse side is equal to the sum of the squares of the two opposite sides. So our hypotenuse side is the side that is facing this was 90. So we have 10 squared is equal to c squared plus h squared. 10 times 10 we have 100 is equal to 36 plus h squared. Take this one here. 100 minus 36 equals to h squared. So we have 64 equals to h squared. So to get our h, we are going to square root both sides. Square root of 64, square root of h squared. Square cancel square roots. My h equals, so square root of 64 is what? 8. So we have 8 meter. So with the distance of the foot of the ladder from the wall is 8 meter. Furthermore, if the ladder is now moved so that the foot is 2 meter further away, meaning that when you drag this ladder forward, it's going to come down this way. Let me use a dotted line as we do the other time. It's going to come down. Let me say it's come down to this place. Definitely, is the foot also will be displaced. The foot will be displaced. Now, we're now told that this ladder moved 2 meter away from the initial position. Now, we now want to calculate the distance here. Let's call the distance here x. In order to get the value of this x, let me still consider this triangle HBF. I've gotten my 8 to be 8 meter. Then the length of my ladder still remains 10 meter. Let me recalculate the length HB. If I can get my HB, I will take away 6 from it. Then it will give me this x. Okay. So the square of the hypotenuse sides, that is 10 squared, is equals to sum of the squares of the two opposite sides, which is 8 squared plus k squared. Then we have 100 equals to 64 plus k squared. Take this one here. 100 minus 64 equals to k squared. So when you take it away, we have what? We have 36 is equals to k squared. So square root both sides. Square cancel square root. My k equals to 6 meter. And to get the value of this x now, since h to b is 6 meter, and I want to get the x, then I have to take away this from this. If you remove 6 from x, so x will be 6 minus 6. Give us what? 0. And you know our height can never be 0 meter. What does this mean? It means that immediately this ladder was adjusted further by 2 meter to this horizontal, the ladder has fallen, meaning there's no height for it. It has fallen off this wall. Immediately it was what? Adjusted further. That's just the interpretation. Because we must not get our value to be 0. Rather, it should be something less than this 6 meter. So this is how to go about this. If you are just joining us on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. So thank you very much until we meet in the next class.